Alright, this video is to help you with scientific notation. More than likely you've seen scientific notation before, but we're going to take you through the basics and then also some applications of it using multiplying, dividing, some powers, and even some real-world problems. So, again, scientific notation is just a great way for us to express really large or tiny numbers, as it says in the green box, with a much more easy-to-read notation, such as the astronomy mass of the Earth. You'll notice that that is 5. A really large number, gazillion, I don't know what that is, grams. Well, we'd much rather refer to that in a number we can kind of grasp. Okay? So what we're going to do is we're going to move that decimal place. And to write in scientific notation, the biggest idea is that n is going to be a number between 1 and 10, that number in front of the multiplication. And then we're going to refer to things as their order of magnitude, essentially, 10 to the power of. That's going to handle that decimal place. So if we were looking at a number like 5, 9, 8, and all those zeros, what I'm going to do is count how many places my decimal needs to move to the left in order to place it directly between my 5 and my 9 right there. So I've got to go past 3 decimal places here, make 6, 9, 12, 15, 18, 21, 24, and then 27 decimal places. So what's going to happen is I'm going to take 5.98 and I'm going to refer to that times 10 to the 27th. Okay? Because that would move it 27 decimal places. Similarly, we can revert the other direction. So if we're looking at molecular chemistry down here, the mass of an electron, 9.1 times 10 to the negative 28 grams. Well, a negative exponent, remember, makes a reciprocal. So that's 1 over 10 to the 28th, or basically making a decimal place. So if we refer to that one, we're going to move that decimal past the 9. I'm going to move it to the left, because I want to make this into a decimal. And then I need to move it at another 27 spaces. So you'll notice I've kind of lopped them off in 5s, but here's 5, 10, 15, 20, 25, and then to get past the 0, 0, 9, that would be 28 full decimal places. Let's try that with some slightly smaller numbers. So if I want to write things that are large numbers, numbers that are originally greater than 10 in scientific notation, what I'm going to do is, again, imagine where my decimal place needs to be to place it right after that first digit. So 3.76 is going to be my front number. Then I'm going to multiply that times 10 to the, and how far I had to move that decimal will be my exponent. So I'm going to look at it and say, okay, I had to go past 3 zeros, as well as the 7 and the 6. I moved it 5 total decimal places. So 3.76 times 10 to the 5th would be a good way to write that one. Same thing down here. If it's an original number that's less than 10, again, I'm going to move my decimal to the right. So this time I'm going to say, again, 3.76. But in order to get that decimal from here over behind the 3, I'm going to have to go past 4 decimal places, but realize I moved them to that right side. 3.76 times 10 to the 4th would technically be 37,000. If we make that a negative 4, just as we had down here, that makes it a decimal. So that tells me that my original number must have been less than 10 or less than 1. Hopefully that helps with the scientific notation. So let's move along to multiplying and dividing. The beauty of scientific notation is it helps us deal with large numbers. So in order to multiply or divide scientific notation numbers, what we can do is multiply the number in front, okay? And then we're also going to multiply the order of magnitudes. So I'm going to take 1.4 and 7.6, and I'm going to take 10 to the 4th and 10 to the 3rd. All 4 of those numbers are just multiplied, so I can multiply in whatever order I want. So if I take 1.4 times 7.6, I'm going to get 10.64, and then 10 to the 4th times 10 to the 3rd, I can use my product rule, product of powers, and that is now 10 to the 7th. I'm going to add my exponents. Now, if that's 10 to the 0.64, though, that's not good scientific notation. So again, we're going to move our decimal 1 space to the left, and we're going to call that 1.064, and that would be times 10 to the 1st, a number that was greater than 10 when we started. But that times 10 would move us back to 10 to 10.64. There's my front number, 1.064, and then I just need to recombine again my magnitudes. 10 to the first times 10 to the 7th becomes 10 to the 8th. Same thing goes for division. I can divide 1.2 by 4.8 and divide 10 to the negative 1 and 10 to the negative 4. Remember that that's the division rule, so I'm going to subtract my exponents. Negative 1 minus the negative 4, okay, over here, which becomes 10 to the 3rd. And then 1.2 divided by 4.8 is 0.25. Again, not good scientific notation. So I need to change that into a 2.5. And again, I moved my decimal to the right, or I had a decimal when I started, so that needs a negative exponent for that negative 1. I moved it to the right 1 unit. Then I can recombine my magnitudes. Again, add becomes 10 squared, and we're in good shape there. Same thing goes with powers. Remember, we can take a power of two things multiplied by just applying that power to both parts. So that's going to be to the 3rd, and so is the 10. So that's 4 to the 3rd, 10 to the negative 2 to the 3rd. 4 to the 3rd is 64. Power to a power tells me to multiply to get negative 6 up in that exponent. And if I take 10 to the negative 6th, again, 6.4 times 10 to the 1st would represent 64. Combine my magnitudes, and I've got my 10 to the negative 5th. So again, easy ways to apply those numbers without having to deal with all those decimal places if we were doing that in real big numbers, such as this would have been 0.04, and now I've got to take 0.04 cubed. Again, you can lose track in the details. Much more straightforward with scientific notation. How can we apply that to the real world? Well, basic idea. The Amazon River in Brazil contributes more water to Earth's oceans than other rivers. Each second, it discharges 4.2 times 10 to the 6th cubic feet of water into the Atlantic Ocean. We want to write that amount of water per second, right? Because it's contributing that every second into standard form. So standard form would be just a regular number. So if this is 4.2 times 10 to the 6th, I can go ahead and start by writing 4 and 2. I need to move my decimal past the 2, so that accounts for 1 decimal place. I need to go 5 more. So I'm going to write 1, 2, 3, 4, 5 decimal places. And that would be 4,200,000 cubic feet per second. I apologize for the handwriting. This pen is a little tricky. Then, how much water does the Amazon discharge into the Atlantic Ocean every year? Well, basically, first we need to figure out how many seconds are in a year. We know the cubic feet per second. And if we take cubic feet per second times seconds, we can cancel our labels, right? We'll get our cubic feet. So first of all, doing the conversion, there are 3,153,600 seconds in a year. There are 4,200,000, again, from our answer up top here, cubic feet per second. And if we use our scientific notation, right, 4.2 times 10 to the 6th times 3.153 6 times 10 to the, it looks like we moved 6 spots there as well. When we multiply these two, they're going to come out to a large number, so that gets me another order of magnitude, or that would be 13.25, I believe. We move it 1 more decimal place, and we get our final answer. Again, you can walk through those steps similar to the previous screen, but there's what you should end up with. Same thing goes for division. If I want to divide to find the price per acre, the total price, so 7.2 million, well, millions is 6 decimal places, so that would be 10 to the 6th, over 3.78 times 10 to the 8th, and I can reduce that down. 7.2 divided by 3.78, which we can find via the calculator, which is 1.905 times 10 to the, and now 10 to the 6th over 10 to the 8th. Remember, subtract our exponents would be a -2, and that's already in good scientific notation. So there would be our final answer. And again, that's in dollars per acre. Right? Dollars per acre. On there. Right. If you have any questions, make sure you talk to your teacher. Otherwise, good luck with scientific notation and have a great day.